So we are here for a fantastic line of speakers on the lightning talks. So the first up here is Sushma, Executive Director, JP Morgan Chase. Over to you, Sushma. Is this working?
Okay. Good afternoon, everyone. I'm Sushma Chakirala. I'm a director at JP Morgan Chase. For those of you who don't know JP Morgan Chase, it's one of the largest banks in the United States, and it is, we call ourselves a fintech company because of our heavy investment in tech. And India is the third largest technology center, global technology center for JP Morgan Chase. So my current role is, I handle digital production support operations. My co-speaker Varun couldn't show up today; his flight got delayed. But the topic we're going to talk about is alerting. It's a topic close to my heart currently because of my current role. So what is alerting, right? So my current role is actually, supporting a very large platform, Chase.com. It's a banking platform. It has close to 67 million active users. So you can imagine the challenge of, production management operations for such a large platform. I think I don't know how many of you are from development, software development. Okay. How many of you have ever done production support operations? Okay, so I think for those of you who have done it, you will understand the pain point I'm going to share today. So, I think that, you have great products that are released into production, and then the real fun starts, right? You have all these events, alerts, incidents. So what's an event? Event is anything that is happening in your system, any change that's happening in your system. Alert is any change, any deviation from an event. So anything that is normal, but it has changed, is an event. Incident is a disruption to normality. Incident is where something is broken, customers are impacted, and you generally don't want too many incidents. Alerts is really what you see largely in production. So why do you need alerts? Again, most of you in software development, I'm sure you understand, developers love alerting. They love to write logs to catch every single error that occurs. You have your alerts for, most complex systems have multiple layers. You have your front end, you have your middle tier, you have your database, you have your infrastructure, you have, you have all kind of queues. So you have, you have all these 10 different systems which need to work together cohesively to, make sure the application is up and available all the time. So how do you know your system is up and available? You have these alerts which make sure that every component is doing its job correctly, right? And alert is basically, like I said, it's catching, it's making sure any abnormality in behavior is getting caught. So you have alerts for everything. You have infrastructure alerts, database alerts, application alerts, right? You have alerts to catch any change that's happening in the system. The picture on the left basically shows, right? That's how our heartbeat, when you're in an ICU, you see all these different alarms that are going in. It shows, right? Anything that is abnormal starts beeping. So that's what you want for your systems as well. And how do alerts work is basically, most of these alerts are set up for an application where you say, hey, this is a resource I want to monitor. This is the, this is the threshold, this is the, this is our endpoint. Could be a HTTP endpoint. This is what I want to monitor. This is a runbook. This is the action I want to take. And you have all these different parts of an alert that you set up. It's part of your policy. And then it is just rolled out, right? And usually your operations team is actually looking at it day in and day out. So what's a good alert? Good alert is anything that's doing the job. It's telling you when something is wrong and you are able to act on it. Good alert is easy to understand. I think all of us know that. Bad alert is also okay. Any false, so bad alerts can go in two types. It could be a false positive or it could also be a false negative. False positive is, right? You jump into a call because you think something is wrong and then you realize nothing happened. It was a waste of time and you are going back to your desk. False negative is far worse. Many times you don't even know something is broken. Customers are calling the call center, and then everyone is in panic mode trying to figure out what happened. So both of these are not good. You don't want false positives. You don't want false negatives. I think both these are, I think need to be managed. The third category is the most tricky one. It's an alert which says, hey, something could be wrong. You may want to check it. It's like the gray alerts. I think that's an area which is, I would say, most challenging because you're kind of predicting that something could be wrong. You need to jump into it. So I think gray alerts is something, we need to, I think you need to catch and tune it carefully. So why are we talking about alerting? The pink bar at the bottom talks about it, right? Why do we even care? Because alerting is, for somebody who's been in production, knows, I'm sure you can empathize with the pain. It can be a pain because there are just too many alerts which are beeping from all directions. You're getting paged all the time. So I think good alerting is important for the product. The product is up and running, stability of the product. It's also good from a right resolution. You are able to detect, make sure the application is usable. Finally, it also is important for the teams. Your team is happy, your morale is good, right? Employees are happy, productivity is good, you're not interrupted from your day job. So there are many reasons why alerting by itself can be a game changer for how you handle operations. Okay, so I think we talked a little bit about it. So most traditional operations team, right, you have this huge volume of alerts which are, getting into your mailbox. What do we do when we have an overload of mails in our mailbox? We tend to auto-archive it. Hey, sir, this is not important, we'll auto-archive it. We also tend to suppress. Hey, this this is a regular issue, it always happens, let's suppress it. Third issue that we see is that, we have an alert, but no one really knows what's broken. So what? What is the customer experience? What is broken, right? And finally, I think alert fatigue basically says that you have so many alerts that you stop responding because none of them actually make sense. They're not doing what they're supposed to do. So I think this actually shows why, right? What are some problems with alerts? Why do we see this, right? If all of us know that we need to have optimal alerting, why does it even happen? So this, basically it's because no one really plans for, I need to design this alert up front. You do your development, you push your code, you catch some errors, exceptions. Every team, every component is doing its job and pushing their alerts into production, right? And it's not part of a design discussion. And very often they may not be aligned to your SLOs, which is basically your objectives, the purpose of the product. What is the main objective of the product? What is the critical user journey? So it's not often tied into the right SLOs. Third, I would say reason is that all of us are a little. You want to keep your threshold loose in the beginning because you're saying, okay, let me catch and see if my code is even working in production. Let me keep it little looser, and then we can tune it later in production. So third, it's a fear that we keep thresholds loose because eventually you want to fix it, tune it in production. Fourth is, I think most of us know this product generally focuses heavily on features and speed and less about operational hygiene. Unless you have been in that seat, you wouldn't really understand what are the operational challenges. And I would say unless you've been in on-call and you've worked in that place for a few years, you may not even appreciate the pain point of production operations. Finally, this, good alert is very hard to measure. Signal noise ratio is very hard to measure. It's not very easy for somebody to say, hey, this is good, this is bad. It takes a lot of work. So actually measuring the alerts is not an easy job. It's pretty tough. Okay, so now I think we've talked enough about the problem. We're going to talk about the, how do we take care of it? Like I said, there are 4 boxes. The critical and the low alerts are easy. It's really about starting to prioritize the alerts. Start with classifying, saying, hey, these are my most critical ones. If this is down, the application is down. We need to take care of this first. These are my P1 alerts. They need to be paged. They are urgent, right? And separate those. These are your critical alerts. Low priority, I think it may be one of the servers is down, but that doesn't mean your entire application is down. On most cloud-based systems, you have auto-scalability, you have resiliency. You don't really need to worry about one system going down. Your application is up and running. So those could go into your low alerts where you need to take some action, but you have some time. Then the two boxes medium are the, like I said, are the ones where you need to spend most of your effort, because these are the ones you need to tune. Right, so short term, I would say most of the operations team who are working in a, right, who have not yet gone into their SRE models, they start by creating a baseline, and right, you start looking at trends, and then you see how are you reducing noise over a period of time, and then start measuring all the deviations, right, anything that you see, reduce your noisy alerts, and don't make your threshold static, which is saying every day, every time this is my threshold. Your threshold may change based on season. You may have Thanksgiving, Black Friday, you may have higher volumes. Nighttime, weekends, your volumes could be different. So your alerts need to be tuned based on the situation and the context. Fourth is some of the noisy alerts is because maintenance. We generally try to suppress alerts so that reduces your unwanted noise in production. And then as you're going into a more modern way of working, into SLO based, right, where you are working with less around components, you worry less about your components going down, you look at more of the customer journey, you look at is the customer really impacted, and you focus more on customer journey based alerting. And then also I think again, most of you who've been in site reliability engineering would know that things will go down, systems will go down, and it's okay to have a few failures. So have an error budget which says this, 0.5% failure is okay, or 0.05% is okay. And you start measuring your burn down, and you say, okay, over the year, I'm allowed to have these many failures, and these are the failures, right? This is when I need to start, taking action. So I would say start with a very traditional way of working, where you focus on your operational tuning improvement, and then move into a more SLO-based alerting. Okay, this is the final slide. So what are the best practices for alerting is, I think you focus on MTTD, which is mean time to detect. This needs to be thoughtful. If you want to detect something that is going to go down, it needs to be part of your alerting prioritization. You need to think very upfront that, okay, if this alert triggers, it means the system is down. I need to take care of it immediately. So I think looking at that. Second, as I said, is right, make your thresholds very adaptive, which adjust based on the situation and the time of the day. The second point is MTTR, is your mean time to resolve. Very often your alerts go to the entire world, and you are just waiting for one good person to go act on it, right? Make sure the alert is reaching the right person, and it has a right run book where you are actually saying go and take this action. That's the only way you resolve the time to actually fix something in production. And for MTTR also, you will see in most organizations you're relying on a critical few people, heroes who are actually doing all the work. So reduce the tribal knowledge, have standard run books so that it's actually the information is available for anyone to act on. Finally, from a culture perspective, it's a journey. Like I said, you're moving from a traditional operations to a modern way of working. You create a culture where alerts are treated as signal, right? Even if it's a proactive alert, you don't sit on it. You actually react to it and take some action on it. And you're, there's a sense of urgency at all times, even if it's a less critical alert. Finally, I would say the on-call person, it's best if the person also has the privilege, authority to go and fix them on the fly, because that just leads to further delay. So I think finally I would say that a good alert, it has all these different parameters. It's a resource. You're capturing a metric. You're looking at a function. How do you aggregate it? What kind of function? Are you looking at the average or mean or max, right? Or a percentile-based alert? You may also use some tags to kind of group it, right, to catch some of the transient alerts. And finally, these alerts may be triggered into your mailbox, maybe to a tool. There are many good tools. I'm not even covering tools in this topic. I'm just talking about the practice. But there are almost every cloud tool, every tools that are available have the ability to capture your alerts. And finally, the last point is alerts a good alert can quickly become bad if you don't maintain it. It's like your garden, right? You have to continuously weed your garden. It starts growing quickly. So you need to make sure you are your ongoing effort to weed the garden, remove the bugs, clean it up, and make sure your alert quality stays the same, and measure and monitor. I think that's about it. That's all I had for today. It's a pretty short lightning talk. Thank you. Okay. Do you have time for questions? Time for questions?
Thank you, Sushma, for such an informative talk. I'd like to call upon the session chair to do the felicitation, please.
Thank you. Thank you. Thank you. Thank you.
Any questions? Any questions from audience? Yeah.
I have my entire team here, so even if I can't answer questions, there are many people here who can answer.
Sure. Hey, hi. My name is Pooja. First of all, great session on alert noise reduction. So, at the end of the day, we have to solve the MTTR and MTTD for a customer. So, how do you solve the onboarding problem or the cold start problem for onboarding of alerts? Because many a times we saw customers are not setting the alerts at all, and we have to reduce the MTTR and MTTD.
Okay, I don't think I could hear, there's an echo, but I think you're asking about how do we solve for onboarding an alert, right?
Onboarding problem for, customers, so that they can create the alerts at first, or one way is like human interaction in between. What is the engineer way of doing so?
Yeah, so I would say one way is of course gating, right? Of course you publish your best practices saying these are the alerts, this is what you need to have. You have a gating criteria which says you don't push any alert to production till you are meeting a certain, gating criteria. Third is you need to go on call. Only then you will know what's working and not working. You need to feel the pain of the alert. I think that's why most companies are going into a modern way of working. You build it, you run it, because unless you're there, you won't really know what's working, right? And I would say gating, right, and setting a practice. Start small, maybe with a couple of products, and really think from a customer perspective, right? Don't think about it from a developer perspective. Hey, I need this log, I need to catch something. Really think from a user perspective, right? What is the impact? Is this really impacting a customer experience, a journey, right? And only make sure those are critical, and there is a critical alert, you're getting paged, right? And have an escalation matrix.
So to solve this onboarding problem, are there any golden signals on which you are creating some out-of-the-box alerts using this dynamic thresholding that you mentioned?
Yeah, I didn't cover it today, but that's a whole topic by itself, right? How do you actually monitor golden signals? But again, I think golden signals also you're monitoring at a product level, or you may be application level, or you may be monitoring at a larger journey level. But yeah, you can. I think that's why you need to look at what do you really need to monitor, right? As a developer, what do you need? Do you really want to know when your latency is important, right? What is your objective? Is your latency important? Is your throughput important? What is the SLO you have signed up for? So that's why I think you need to. I would say the better way is you have alerts based on SLOs, but many of us are in the journey. You're going from traditional operations to a more SLO-based alerting.
Yeah. Thank you.
Okay. Thank you.
Thank you, Sushma. In continuation to our session on the lightning talks of use cases, our next speaker is Kokilavani Kadiresan, Engineering Manager, Intuit. Over to you, Kokila.
Hello everyone, a very good afternoon. I'm very honored to share this talk. Sorry, I didn't get the things. Sorry for that. Yeah. Which one is this? I'm very happy to share this talk to everyone. So this talk mainly focuses on the kind of tips that helped us in saving quite a lot of cost with respect to observability data. Quick show of hands. How many of you heard of the term observability? There you go. It's kind of a buzzword in the industry, right? So observability is mainly about understanding the internals of the system. Think of it as a big comprehensive data store that contains logs, traces, and metrics. It's kind of a digital breadcrumb. You can navigate through these data and derive some insights about your system's behavior. Observability is not only about a technical jargon. It has more towards it. It's kind of a gateway to unlock your profound insights about your system performance, customer experience, holistic insights about your business. Observability is not only about monitoring, It's about understanding what is hidden behind your data. That is where observability's true picture comes in. And that is where the true magic lies on. So now you know what is observability. Now we know why it is important as well. It provides better visibility, safer monitoring, better business insights, which in turn provides better user experience. With respect to pillars of observability, we have logging, metrics, traces. Along with that, if we empower that with an AI ops, there comes the true magic. At Intuit, we use observability for multiple purposes. One such thing is, how do we reduce MTTR? I understand someone questioned about MTTR during our previous session. So, during an incident at Intuit, we track 3 different types of metrics. MTTD, mean time to detect. How fast you detect a problem from the moment it had happened before someone complained about it. MTTI, mean time to isolate a problem, which is mainly about how easily you identify where the problem is, given the system is highly complex in nature, along with distributed services plus multiple components. Then comes the final phase, the recovery phase, MTTR. So our ultimate goal is to reduce the MTTR. How can we do it? That is our main purpose. This talk, I would like to focus mainly on the distributed tracing and how did we use it. People would have heard about distributed tracing, right? It's a mechanism to track an individual request or a transaction across multiple microservices. Let me go back to this one. This is one of the trace view. This entire thing is called a trace. Single line that you see is called a span. So what this trace talks about is, this request originated from gateway, it went to billing commerce in turn called entitlement service via gateway. So now let's say during an incident, if I present this view to a developer, it will be very easy to identify the problem, and once it is identified, then it is about involving right people and get it resolved. Going back to the challenges that we had at Intuit. With respect to tracing, we had to deal with around 8 million spans per second of volume. With that, we need to have a better backend system that is auto-scalable without any human intervention. Similarly, we should also keep the cost in mind. We should not exploit the cost. We should also account for the future growth as well. So with all that in mind, we had designed an architecture. All our workloads run in Kubernetes clusters. So the top box that you see there is a Kubernetes environment. We use OpenTelemetry for tracing. So we had deployed the OpenTelemetry agent inside the cluster, which is running as a daemon set, which takes the data, sends the data to Amazon S3. Trace ingester is our own backend. This service takes the data from S3, processes the data, sends the data to Grafana Tempo, which is our raw backend, and we store some indexed data in Elasticsearch. Why we need this index is, the view that I had shown before, people used to filter the attributes. The attributes could be service ID, region, environment, whether it is an error traces. They could use multiple filters to land upon the traces. So Elasticsearch is used for that. The UI that I had shown is called a dev portal fuzzy. User comes to the fuzzy UI, hits the API, it connects to these two data sources, surfaces the results. You know what? This worked very fine. When we deployed it, we were all very happy. Functionally, it was fine. The latency wasn't sub-second. Everyone was very happy about it. But you know what happened? After a couple of months, our cost took a hit. It was like a very high costly solution. We have to think about it. Then we went ahead to the cost attribution. On checking, we saw that Trace Store, which is nothing but a Grafana tempo, attributed for around like 42%. Indexing Store, which is the Elasticsearch, attributed around 34%. So now we know like we have to do something about these components. It's like very expensive. Apart from cost, the other challenges that we had was with tempo, we had faced some issues while scaling. And also we had this sinusoidal nature of traffic, which is like during ID's India hours, it would be lesser traffic. During US hours, it was like a higher traffic. So with that, it makes sizing very difficult. So with all that into consideration, we thought about our new tracing architecture. While considering, we had taken into account of these factors. One thing is, what is the ingestion volume versus query volume? Like how many data is being ingested to our backend? How many people are really querying the data? We got around like 8 million spans per second, around 50 QPS of query volume. And how many attributes are really ingested? How many attributes are really used for querying? So there are like quite a lot of attributes getting ingested, but only handful of attributes were getting queried. Similarly, we had a sub-second latency. Do we really need to have a sub-second latency for this use case? Can we take a hit with respect to the other challenges that we had? These are all the further considerations that we had while redesigning our new architecture. Then we felt this is a good candidate for a columnar storage. This is our revamped architecture. Though it's mentioned in the screen, it's not this simple. We had a very complex components in between, but just for a simplicity, I just extracted it in a high level. So from the trace ingester, we removed the tempo, we removed the Elasticsearch. We stored the data in Amazon S3, which is a low-cost storage, but we have stored in a Parquet format, which is a columnar one. We had 3 different buckets. One to store the raw traces, one to store the search index, which is for the indexing. Next thing is the metadata, which gives some information about the common metadata. Then we use something called stateless query engine. Here we had used a ClickHouse. ClickHouse is used as a stateless query engine to query the data from the S3 and display it back in the UI. And you know what? This solution has had a monthly savings of around like 69%, which was like a really big thing. One small problem with this solution we had was there were multiple small S3 files that were getting created, which had a problem when we had to query the S3. The S3 API performance was taking a hit. So we thought through that, and what we did was we introduced a compactor. This compactor is responsible for getting like last 5 minutes data, compacts it as single S3 file, inserts it back to S3. So now with that, even though we query like a fuzzy layer, if you go back. So whenever the fuzzy, there is an API call from the fuzzy, the ClickHouse has lesser number of files to query because of the compactor. So this is the architecture comparison I had. Like from Amazon Elasticsearch and Tempo, we went to S3 based backend in a Parquet format plus stateless query engine, which is ClickHouse here. The key takeaways. In our case, the data scans were very relevant towards the columnar storage. So we went towards that, which had an overall cost savings of around 69%. We could successfully scale around 8 million spans per second, and it does not impact the increase in traffic. Because it is S3, we could scale as much amount as we want. We don't want to worry about like how much the load we are receiving. With respect to the attribute indexing, we do not have any limitations because it is a Parquet. We can add any number of columns to it. Service owners have a title control over cost. So that is also another big advantage that we had. Yeah, that's it. Thank you.
Thank you for sharing your expertise, Kokila. I'd like to call upon a session chair to do the felicitation. Before that, we would like to take questions. Do we have any questions for Kokila? We have one there. We need a mic.
Great presentation. With such large data sets, have you explored any other tools apart from this? Like in Expedia, we use Datadog, and it has massive capabilities for tracing and other stuff. So, did you explore any other tools as well for your use case?
Datadog, you mean?
Yeah.
No, at Intuit it's all homegrown. See, we just use open telemetry and open source for instrumentation. Everything is like homegrown solution. We don't use any vendor products.
Okay.
Yeah.
And I wanted to ask, over the time the data will keep growing. So is there any purging strategy or things that you have implemented?
We have a retention of 30 days. So we'll store only 30 days data, the other things will be purged.
Okay.
Yeah.
Thank you.
Thank you.
Any more questions? There's one here. The mic is not working. Can you please check? Excuse me.
Check. Okay.
Yeah.
So yeah, thank you so much for the presentation. So I'm Divya working with PayPal. So I had few queries regarding the AI ops you mentioned. So it was mentioned auto remediation. So I just want to hear more about it. Like probably how do you do auto remediation using AI?
Okay, right now with auto remediation, what we do is we auto scale. Like many a times the problem is with the spike. So if it auto scales, it recovers automatically. So right now we have only that level of intelligence. So if we feel that auto remediation is auto scaling is a right solution, we'll just go ahead and do it. That is the only intelligence so far we have, but we are working towards like the actual remediation without human intervention.
And second one is the follow-up with what she said. So you said 30 days retention is there for the data, right? So what about metrics, etc.? Because other open source tools give a metric retention for over 6 months.
Mm-hmm.
So wouldn't that be a problem in that case?
Okay, see, trace data, right? No one will look at the trace data that is older than 30 days. It doesn't make sense at all. So this is mainly during the moment of an incident. That is where this data is very active, which means that is where the data is really being used. Let's say you are recovered from an incident. Maybe over a week, you may need to analyze what had happened during that moment. You may need to go back and understand the data. But we did not find any use case where a user want to go back 30 days old data and take a look at it.
No, thanks for that. So I just wanted to understand on the metrics part. So metrics, the graph, etc.
Metrics had a retention of 6 months. Yeah.
Okay, that was
Only traces part, it's about 30 days. Yeah.
Yeah. Thank you so much.
Thank you.
Thanks, Kokila. So I'd like to call upon the session chair to do the felicitation, please.
Thank you. Thank you. Yeah. Thank you, everyone. Thank you, GHC.
In continuation to our lightning talks on use cases,
Yes.
our next speaker
This
is
is back.
Shirsha Ray Chowdhury, Director, Research Engineering, Thomson Reuters. Over to you, Shirsha.
I hope you can hear me. All right. So I'm here to give you a lightning talk on a topic that I've been personally studying the last year, year and a half. But before I get into that, I think I want to thank all of you on a Friday afternoon after lunch, sitting here to listen to me talk about what I studied the last year and a half. I'm really grateful to have you listening to me. Little bit of an intro. I have about 22 years of work experience, having worked in different domains, telecom, automobile, legal tech now, and I have dabbled in various roles, right from field support, software engineer, to infra support, to now working as part of the labs team at Thomson Reuters. And in my current role, we look at building forward-looking features which leverage generative AI in our products. Our products are all about doing legal research, and hence they crunch a lot of textual data. Needless to say, the spot is really fertile for leveraging generative AI. And building solutions with generative AI opens up a new world of problems. I'm hoping I can take you through some of the challenges that we've experienced and what we're still missing in this space with observability. So here's my topic. Here's what I'm going to cover today. First of all, I know all of you have heard about observability from two really good experts, so maybe just a very superficial definition of what is observability. And then plunge right away into what do I mean by observability in AI versus typical software solutions. Then look at observability with generative AI, and here's where I want to take you through some of the challenges that I've experienced as part of my projects. No talk on AI is complete without being balanced with the ethical considerations. So obviously, what does observability and ethics got to have together is what I want to talk about. And a little bit perhaps about what gaps still exist and what future trends could we expect. Why do we need observability? I'm sure the previous two talks have established that really well, but just to repeat, of course, developers need their logs. Of course, we want to be able to debug and investigate production issues. We need to monitor health of systems. Well before they are fully dead, we want to be able to, pull in backup. We want to collect user feedback, right? No point putting up solutions and going to sleep. We want to know how we're doing. We want to be able to manage the data that is flowing through our systems. We want to be able to run evaluations. We want to be able to capture those conversations that the user is having with our products. And since a lot of this is today built around prompts and how we use generative AI, so obviously prompt management is also something that we need observability with. So what I want to do is maybe take you through where these have a role to play across the generative AI build to production workflow, right? So here's where here's how I broke it down, and you may break this down very differently in your organization. But when generative AI came to us as a new technology, we didn't have a well-defined life cycle associated with it. But now here's this pattern that we see, right? We always have a POC or a feasibility study. Can this work for us? Will we be able to really pull out answers of this quality? So there's this whole POC phase, right, where we are building the solution. We are, of course, doing quality testing. We are building and testing with maybe beta users of our MVP. And finally, if all goes well, we end up doing the GA. Now, across these 4 life cycle stages, what different aspects of observability do we need, right? And there are 2 aspects of why we need the observability. We need it for ensuring we are building solutions for customer delight, and we need it to ensure that we are meeting operational efficiency, right? So during the POC stage, we need traces. Of course, developers need to build solutions right. We need to be able to debug. And with LLM vendors and their ups and downs, this is very crucial even in the POC stage. We want to be able to establish what aspects of the conversation or usage of the product do we want to capture as part of the sessions. And of course, we want to monitor it, right? We want to monitor, profile the CPU usage, we want to profile the memory usage, because all of these are, like very new world for most of us. When we are testing, of course, we want to continue to look at traces, and we want to be able to debug issues and capture conversations, monitor the system health, but we also want to manage the data sets which are used for the testing. So here's a new thing that we'll probably need to add as part of testing AI solutions, right? And of course, we want to be able to evaluate how we are performing around the metrics associated with the AI, but also perhaps tie it with the business metrics. And then the MVP. The MVP, the first four, of course, are default, but the MVP means we are opening up the solution to fresh eyes, right? And we want their perspective, and hence we need to gather the user feedback. And finally, when we are looking at, opening up for GA, of course, we need all of this, but perhaps the data set management will lend itself to some privacy considerations. Here's where I needed the video to play, but if it's not, okay, let's try that.
The journey between human question and AI answer is complex and unpredictable, but AI is still software, and I'm still in charge of it. I need to go deep into services, frameworks, models, and databases, and also see end-to-end. I need APM that can handle AI. And with New Relic, I have it. Inside the all-in-one observability platform, New Relic alerts me that AI response to negative feedback, error rates, and token usage have spiked. So I drill down to an interaction with negative feedback and trace the logic behind it. Whoa, I can see every leg of the journey, track which touched the AI that helps with compliance, and then go deeper. I click into the error, see inputs, outputs, and other metadata. Okay, there's an issue with how my service transforms the data from the model. I fix it in code. Done. Finally, I compare models to find the least expensive, highest quality option. So I can save money and turn those thumbs down, up. And you can too, because the New Relic makes your AI stack just as observable as the rest of your software. Start now with more than 50 ready-made AI integrations. Control for speed, cost, quality, and compliance. And never ever fear complexity. New Relic AI Monitoring, the latest in observability and the first APM for AI.
Thank you. So this is not an advertisement for New Relic at all, but I thought this short snippet of a video told the story of why we need monitoring aspects a little differently for solutions with generative AI. Just going back to that, what happened, right? So you started off with noticing business metrics or SLAs for your product falling or shooting up, error rates going up, and that's compounded with token usage shooting up as well, which means people are trying the same query repeatedly, which means you now have to understand what's going wrong. You immediately want to go into your traces, you want to see which is your error in that whole workflow, right? And now with the way we've been starting to build out the Gen AI solutions, it's a full-fledged stack. It's very, very elaborate workflows. So across the different service calls, you want to know which one has failed or which one is continuously failing, and then tie it to perhaps you've not covered for that corner case, right? And then fix it and go back to evaluations and releasing the solution perhaps. I'm making it seem really rosy and that it's possible to investigate this quick, but in reality, it takes us quite some time to figure out what to do around issues when things go wrong with LLMs or they don't work as expected or we start to see hallucinations on the rise. So let me continue. I'm going to continue with few more such challenges that we see as part of our solution development, right? There is a continuous need for us to capture the user's usage of tokens and feedback and API hits. Most of this is not new, except for perhaps the token. because that is somewhat indicative of, what leeway do we have with the solution stack that we've set up. And this needs to work well for us if we have to plan for scaling. The second thing is the need to combine user feedback with traces. Perhaps most of you have homegrown solutions where you already do this, but this becomes even more important with the generative AI solution because you're not somewhat fully in control of all that's happening. And thirdly, this whole thing around managing your data sets. You want to uncover some of that behavior of what went wrong and perhaps replay or perhaps consider it for, product improvements. You also saw that, sometimes in, let's say, when you're trying to book the ticket or, you're using Make My Trip uses very good generative AI solutions. They probably also want to store the prompts which work, and they may be looking at doing A/B testing with their solution. So prompt management aspects need to be combined with observability just so you're able to, on the fly, look at what prompt worked best with which version of the API. And finally, like I said, no talk on AI was complete without the ethics angle. So we should be able to, monitor an AI solution, particularly for the fairness and bias aspects, right? And, if you're opening up solutions, we are here today in GHCI. So obviously, the whole aspect of, the solutions not sounding right from an ethics standpoint is unacceptable. I attended a talk earlier today where they said, when somebody prompted the large language model for, give me an image of a nurse, the first picture that it gave was that of a woman. Give me a picture of the doctor, and it gave, a guy. And so these are aspects perhaps you want to be able to monitor for as well. There is perhaps today limitations in terms of what you could do because you're probably using a vendor-provided large language model. But I think the first step to solving the problem is awareness, and so it's important to collect metrics there. And, given how, omnipresent generative AI is becoming, it's becoming easier and easier to uncover vulnerabilities. Prompt injection attack techniques, every day I hear of a new method, right? And hence, security and vulnerability monitoring as part of your generative AI stack becomes equally important. You also perhaps need newer forms of data and insights so that you're able to tie that back to your product insights. And just as important is ethics, equally important is the human who is building the solution and for whom it is built, right? So how do we use observability? How can we uncover more trust in the system using monitoring aspects? How do we collaborate with the subject matter expert? What can we take of a live system back to the subject matter experts who helped us build the solution? What is that collaboration scene going to look like? And finally, the data privacy and the audit aspect. You are storing conversation logs. Can you still guarantee the data privacy? What audit aspects should we expect as generative AI solutions take over our world? Here are a few more challenges, which maybe I haven't encountered all of them, but definitely, several forums are talking about how do we handle this. The model complexity. Do we want to be able to, monitor the complexity of model? And perhaps this is not just for large language models, but also narrow AI models. How do we, the system complexity adds another layer of, monitoring requirements, the interpretability of metrics and associate the model's performance with business metrics. How do you correlate the two? Is it possible to bring in aspects of that with the monitoring tool? The feedback mechanism. How do you interpret a thumbs up, thumbs down? Your users are not always going to give you a thumbs up, thumbs down. Would you want to interpret the repeatedly, when the person is asking the same question as negative feedback? So then flawed feedback mechanisms, I guess, become more layered. There are just too many tools doing little things today. And so I think this makes it a very complex world for us. How do we get them all together and make them talk to each other? the alert fatigue Sushma talked about, how do you characterize your alerts and give them the priority that they need in your game? And of course, I think across different teams in an organization, there are silos. I may have a certain perspective, but how do I take it to the team that's actually going to do the operations for it? How do we bring consistency across the different teams in an organization and make them focused in the same direction, I guess. And finally, I think I want to leave you with this. These are some key observability aspects, from ones which are most prominent to perhaps the lesser known ones, right? I'm out of time, but these are a few tools that I've played around with, and I'm sure many of you have used these as well. Thank you.
Thank you, Shrisha, for such an informative talk. Do we have any questions for Shrisha from the crowd? Okay, we are good. So I'd like to call upon our session coordinator to join us on stage to do the felicitation, please. Thank you. Moving ahead, let's